You know how sometimes there are these big shifts, things that just fundamentally change how everything else works?
Yeah,
Well,
definitely.
today we're diving into one of those microservices. I mean, think about the sheer scale of something like Netflix. All those streams, personalized recommendations.
Or Amazon on Prime Day.
Exactly. How do they even manage that complexity without, falling over? Turns out the engine humming underneath, often it's built on microservices.
That's right. And we've got this great video as a starting point, and it really it shines a light on how these complex systems get put together. It makes it surprisingly understandable, actually.
Okay.
So our goal here for this deep dive is really for you to walk away with a solid picture. What are microservices? The core ideas, why they're such a big deal, where you see them every day,
Right.
what to think about if they come up in, say, an interview, how the basic pieces fit together, the common problems.
The pitfalls?
Yeah, the pitfalls and even where it's all heading. We want to get you equipped with all that, but, without making your head spin.
Okay, sounds good. So let's get right to it. The big question. What are microservices, really? Like, fundamentally?
Okay, so in essence, a microservice is a small, pretty self-contained application. It does one specific job and does it well.
One job.
Right. The video uses this fantastic analogy. Think of a restaurant kitchen.
Okay.
Instead of one, like, super chef trying to juggle everything, appetizers, mains, desserts, everything.
It sounds stressful.
Totally. Instead, you have specialists. Someone just doing appetizers, another chef focused only on desserts, maybe another on grilling. Each has their zone, they work independently, but it all comes together for the final meal. That's kind of the spirit of microservices.
Ah, I see. So instead of one giant software application trying to handle everything that monolithic thing we sometimes hear about,
Exactly, the monolith.
you're breaking it down. Smaller, specialized units.
Precisely. Think of that monolith as the single chef juggling dozens of orders in one huge kitchen.
Hmm.
All the functions, payments, inventory, user accounts, they're all tangled together. One big lump of code. Microservices untangle that. You'd have, say, a dedicated payment service, an independent inventory service, a totally separate user account service, and so on.
Okay.
And the really crucial bit is how they talk to each other. They communicate using standard ways, often through things called APIs, application programming interfaces.
APIs, right?
Yeah. The video even shows this visually, which is helpful. It shows the big solid block of the monolith kind of breaking apart into this network of smaller connected pieces.
Okay, I'm starting to get the picture, that architectural shift. But why? Why go through the trouble of breaking everything up? What are the actual upsides?
Oh, there are some really compelling reasons. The video zooms in on three key ones. First up, scalability.
Scalability.
A
Okay.
bluff monolith, if one part gets slammed, like maybe the product browsing page on an e-commerce site during a sale,
Yeah, that happens.
you often have to scale the entire application, pump more resources into the whole thing, even if, say, the login system is barely breaking a sweat.
Right, which seems wasteful.
It can be. Microservices let you be way more targeted. You can scale only the services that are actually under heavy load. So during that flash sale, you boost just the product catalog service. You don't have to touch the others. It's about putting resources exactly where they're needed.
That makes a lot of sense. Just pure efficiency. Okay,
Okay.
what's benefit number 2?
Agility. Speed, basically. Because each microservice is its own little unit, different teams can work on different services at the same time, in parallel.
Ah, okay.
This means you can develop and push out new features, updates, fixes much, much faster and more often than with a big, tightly coupled monolith where one change can cause unexpected problems elsewhere.
Right, like stepping on each other's toes in the code.
Exactly. Think back to the kitchen. It's easier for the dessert chef to quickly tweak their recipe than for the single super chef to adjust one ingredient in a massive, complex dish they're already juggling.
So faster innovation, quicker updates.
Yeah.
That's got to be good for users. And the third advantage.
Resilience. This one's huge for reliability. In a monolith, if one critical part fails hard,
Like the payment system goes down.
yeah, exactly, it can potentially bring the entire application crashing down with it. It's like a single point of failure.
Okay.
With microservices, because they're independent, if one service hits a snag and fails, let's say, the recommendation engine on your streaming service glitches,
Uh-huh.
the other services can often keep chugging along. You might not get recommendations for a bit, but you can probably still search for and watch your movie. It isolates the blast radius of a failure.
That's a massive difference. Keeps the lights on,
Oh.
mostly. So this isn't just like academic theory, right? The video mentions some big companies actually using this stuff.
Oh, absolutely. This architecture powers some of the biggest apps we use daily. The video points straight at Netflix. They reportedly use over 1,000 microservices.
1,000? Seriously?
Yeah, 1,000 for everything from actually streaming the video to figuring out what you might want to watch next, managing your subscription, billing, all broken down.
Wow. Managing 1,000 services sounds like its own challenge, though.
It absolutely is, but it's what lets them operate at that mind-boggling scale and handle all the complex parts of their platform. Then there's Amazon.
Of course.
The video touches on how their teams are often built around owning specific services. Think about Amazon Checkout, customer reviews, tracking your package, the product search. It's highly likely those are all distinct microservices, probably managed by different teams.
Yeah, you can almost see the seams sometimes, in a good way.
Yeah.
Each part feels focused.
Exactly. Allows for that deep focus and lets each part evolve independently. And Uber got to mention too.
Ah, right.
Their story is quite interesting because they apparently started out with a monolith.
Oh, really?
Yeah. But as they exploded, expanding to new cities, adding things like Uber Eats, that monolith became, well, monolithic, hard to manage, scale, update quickly. The video explains their move to microservices was pretty strategic, essential for handling that massive growth and complexity sustainably.
Okay. Seeing those names really drives it home. This is how you build big, complex stuff that needs to grow. Now, switching gears a bit, for listeners maybe thinking about jobs or just wanting to sound smart in tech chats, what are the key things to know if microservices pop up in an interview?
Yeah, good question. The video had a solid section on this. First off, basic definitions. You got to be able to clearly explain what microservices are and, crucially, how they differ from monoliths. Those benefits we just talked about, independent deployment, scaling, resilience, those are your core talking points.
The fundamentals. What else?
How they talk to each other, communication. That's key. You should know about common ways they interact, like REST APIs, maybe gRPC, and things like message queues.
REST, gRPC, message queues.
Okay. And be ready to maybe discuss why you'd pick one over another. Like, when is speed the absolute priority versus needing to guarantee a message gets delivered, even if asynchronously? Also, designing a basic system is a very common interview question.
Oh, yeah. Like what?
Usually something familiar, like an e-commerce site. Can you break down the main functions cart, checkout, user profiles, product catalog into logical, separate services, and then explain at a high level how they'd interact?
That sounds like a really practical test of understanding. Makes
Right.
sense. Any more technical bits to be prepped for?
Definitely. Data consistency. This is a big one because each service often has its own database.
Right. Not one giant database like in a monolith.
Exactly. So ensuring data stays consistent when a single user action might need to update data in multiple services. That's tricky. You should probably have heard of patterns like the Saga pattern or maybe event-driven architectures. Just knowing they exist as ways to tackle this shows awareness.
Saga pattern, event-driven. Okay, noted. Anything else?
Yeah, just being familiar with some common microservice patterns is good. Things like the circuit breaker pattern, what happens when a service you depend on is failing, or an API gateway, like a front door for all your services. And service discovery, how do services even find each other in this dynamic environment? Knowing what these patterns are and the problems they solve is valuable.
Circuit breaker, API gateway, service discovery. Got it. And didn't the video have like a pro tip for interviews?
It did, and it's a good one. Basically, connect your answers to the real world, or even better, to projects you've worked on, if possible.
Okay.
So instead of just rattling off definitions, talk about how you saw these ideas used, what the trade-offs felt like, or how you would approach solving a specific problem using microservices based on some experience. Makes it much more real.
That's great advice, honestly. Applies to almost any technical interview. Now, what about folks who learn by doing? Did the video suggest any practical steps to get your hands dirty, even just conceptually at first?
Yeah, it laid out a pretty sensible starting path. First step, build something small. A really focused service. Use a common framework, maybe Node.js or Spring Boot. Like a simple user service, create user, update user, get user info, basic stuff.
Okay, start small. Makes sense.
Then the next really crucial step is containerization, using Docker. You write a Docker file, and that packages up your service, all its code, its libraries, everything it needs, into this neat portable box, a container.
Ah, so Docker basically puts each little service in its own container, its own isolated environment.
Precisely. Keeps things clean and consistent. And then the video suggests using something like Docker Compose. This lets you define and run multiple containers together on your own machine.
Okay.
So you could have your user service container running, maybe an authentication service container, perhaps even a simple front-end container. Docker Compose helps them find each other and run as a mini system, so you see how they might interact.
Right, like a mini version of the real thing on your laptop.
Exactly. And as a next step, it mentions maybe looking into deploying those containers to something like Kubernetes. You could use Minikube for a local Kubernetes setup, or even trying a cloud provider's container service, just to get a feel for that next level.
Sounds like the main message is, don't try to build Netflix on day one. Start small, tinker, learn.
That's exactly it. The video really stressed just building, breaking stuff, learning from those small, manageable projects. That hands-on experience is gold for really getting these concepts.
Okay, but let's be real. It can't all be sunshine and rainbows.
Yeah.
Moving to microservices. It sounds complex. What are the common headaches, the challenges teams run into?
Oh, yeah, the video definitely covered the hurdles. One huge one is just managing the communication between all these services.
Right, we mentioned APIs and message queues.
Exactly. When you have maybe tens or hundreds of independent services that need to coordinate, making sure that communication is reliable, efficient, maybe handles failures gracefully, that's a big engineering challenge. Choosing between synchronous calls, like REST, versus asynchronous, decoupled communication with message brokers like, say, RabbitMQ, that requires careful thought.
So it's not just splitting things up, it's figuring out the whole switchboard connecting them. What's another big challenge?
Data consistency, again, we touched on it for interviews, but it's a fundamental operational challenge too.
Because each service has its own database.
Right. So imagine an order process. Maybe placing an order needs to update the inventory service, the payment service, and the customer order history service. How do you guarantee that either all of those updates happen or none of them do, especially if one service fails midway? That's tough without traditional database transactions that span everything.
Yeah, that sounds really tricky, like juggling databases.
Yeah, it is. And that's where those patterns like Saga or event-driven approaches come into play, but they add their own complexity. The video flags these as key areas to architect carefully.
Okay, data consistency. Major hurdle. What was the third one mentioned?
Security. With a monolith, you might have one main entry point to secure. With microservices, you suddenly have potentially dozens or hundreds of network endpoints those APIs each service exposes.
So a much bigger attack surface.
Exactly. Each API is a potential way in, if not secured properly. The video really recommends robust security practices, things like using standards like OAuth2 and JWT for authentication and authorization between services, and often using an API gateway as a single controlled secure entry point to manage access, enforce policies, and protect the internal services.
Makes sense. More doors means you need more locks and better security guards. Now, things will break eventually. What about troubleshooting? Debugging this distributed maze sounds harder.
It definitely can be. Trying to trace a user request that bounces between 5 different services to figure out where things went wrong is way harder than stepping through code in a single monolith. The video stressed the need for good observability tools.
Observability.
Yeah, being able to see what's happening inside this system. Centralized logging is crucial. Using tools like the ELK Stack Elasticsearch, Logstash, Kibana, or similar lets you pull logs from all your services into one place to search and analyze. Without that, you're lost.
Okay, centralized logs. That sounds essential.
And then there's distributed tracing, tools like Zipkin or Jaeger. These let you follow a single request as it travels from service to service. You get a visual map showing which service called which, how long each step took, invaluable for pinpointing bottlenecks or where an error originated.
Okay. Like putting a tracer bullet on the request. That sounds incredibly useful. What else helps?
Health checks and solid monitoring. Knowing the health of each individual service is key. Tools like Prometheus for collecting metrics and Grafana for visualizing them let you see performance trends, CPU usage, error rates per service, and setup alerts. You need to know if a service is struggling before it causes a major outage.
Right, proactive monitoring.
And finally, building resilience in. The video mentioned implementing things like automatic retries for temporary network glitches, using that circuit breaker pattern to stop one failing service from overwhelming others, and having good alerting hooked into your monitoring so the right people know when things are going sideways.
These all sound like non-negotiables for running microservices reliably. Okay, looking forward now. What's next? Where is this whole microservices thing headed? What did the video suggest about the future?
It pointed to a few key trends that are really shaping things. One big one is serverless microservices.
Serverless, like no servers.
Well, there are still servers somewhere, but you don't manage them. Think AWS Lambda or Azure Functions. You deploy your microservice code, and the cloud provider handles all the scaling, patching, infrastructure stuff automatically. It can massively simplify operations for certain kinds of services.
Okay, so you focus just on the code, not the plumbing. That sounds
Yeah.
appealing. What else?
Service mesh technology is getting a lot of attention, things like Istio or Linkerd. A service mesh is basically a dedicated infrastructure layer that sits alongside your services and handles all that tricky inter-service communication stuff. Secure connections, traffic routing, load balancing, retries, observability in a consistent way across all your services.
So it takes some of that communication complexity out of the individual services themselves.
Exactly. It centralizes that logic. And finally, the video just underscored the broader trend towards cloud-native architectures. Microservices are a key part of that, often combined with containers like Docker and orchestration platforms like Kubernetes to build apps specifically designed to thrive in the cloud, scalable, resilient, flexible.
So it feels like microservices aren't just a fad. They're really baked into how modern, scalable software is being built, especially for the cloud. Okay, for listeners who are now super keen to learn more, what resources did the video recommend? Where should they go next?
Yeah, it gave some great pointers. For a deep, comprehensive dive, the book Building Microservices by Sam Newman is often considered the classic.
Okay, Sam Newman. Got it.
Also, keeping up with industry blogs is good. It mentioned martinfowler.com. He writes a lot about software design and InfoQ. Both have tons of articles, talks, analysis on microservices and related stuff.
Fowler and InfoQ. Good sources. Any courses mentioned?
Yeah, for more structured learning, it pointed to online courses. Examples given were things like microservices with Spring Boot on Udemy or Coursera's cloud-native microservices specialization. Lots of options out there depending on your preferred tech stack and learning style.
Fantastic list. Plenty to dig into there.
Yeah.
And was there one final piece of advice, like a key takeaway on building skills?
Yes, and to circle back to the practical side, the final tip was really just build stuff.
Get your hands dirty.
Exactly. Build small projects that use a microservice approach, even if it's simple, like a basic T-Dodo app with separate services for users and tasks, or a weather app that calls different weather APIs via separate services, or a tiny product catalog.
Right.
And crucially, put them on GitHub. Make them public. It reinforces your learning like nothing else, and it gives you something concrete to show people, potential employers, collaborators, whoever. It's tangible proof you can actually do this stuff.
Excellent. Really actionable advice. Build, show, learn. Okay, so wrapping this up, it's crystal clear that microservices are, well, pretty fundamental now. They're powering so much of the modern tech we rely on every single day.
For sure.
So whether your goal is just to, hold your own in a tech conversation, ace that interview, build a killer portfolio, or figure out how to scale your own application, understand these core ideas, the good, the bad, the ugly.
It's a huge step forward. Absolutely. And thinking about all this, the benefits like scalability and resilience, but also the challenges like complexity and communication and data. It does make you think, doesn't it?
Yeah.
So maybe a final thought for everyone listening. Think about an application you use regularly, maybe one that feels a bit clunky or has outages or seems slow to get new features.
Okay.
Considering everything we've talked about, do you think that application could benefit from being re-architected using microservices? And more importantly, why? What specific problems might microservices help solve for that particular app?
Ooh, that's a great question. Puts it right back into the real world. Fantastic. Well, thanks for diving deep into the world of microservices with us today. We really hope this gave you a solid foundation.
Hope so too.
Until our next deep dive, keep exploring, keep learning.